Hello again. Okay, thought I'd just record one more video in case you wanna figure this out before we get back. So this is just finding points of intersection between two lines in 3 space. So remember in class we talked about there's like 4 possibilities now in 3 I just drew like 2-dimensional coordinates. Awesome. Okay, so in 3 space we talked about there being 4 possibilities. Copy, paste. Did that work? Oh, right. Okay, sorry, just give me one more second here. Copy these guys. Paste them. Okay, cool. So we got 4 possibilities. So we've got, we could still have 2 parallel lines in 3 space. We could still have 2 coincident lines, so they're right over top of each other. We could still have an intersecting line, sort of intersected, and then new in 3 space, we could have lines that are called skew lines. And that means that they don't intersect. So they could be like this and like this, but they're actually not intersecting, but they're also not parallel. So skew lines are not, they don't intersect, and they're not parallel. So that's new for 3 space. Okay, so here are 2 equations in 3 space. And we want to find out if they're going to intersect. So right off the bat, I like to look at the direction vectors and just see, are they parallel? So I know if I multiply this first vector by 2, I could make my x-coordinates the same, but nothing else will be. So my direction vectors are not parallel. So I know they're either going to probably intersect, or they could be skew lines, but they're not going to be the first 2 cases. Okay, so what we could do is we can write them in parametric form. That's the best way to go. So this is line 1, line 2. So for line 1, we're going to get x equals 7 plus 2s, y equals 2 plus s, z equals -6 minus 3s. And then for our second line, we're going to get x equals 3 plus t, y equals 9 plus 5t, and z equals 13 plus 5t. Okay, so there's our 2 lines, and we want to find out when they are going to intersect. So, yeah, we're going to do kind of what we did in the other video. If you watch that, we're going to equate the x's. So we know that if the lines intersect, they're going to have a common x, y, z point where they actually meet. So we're going to set the 2 equations equal to each other. So 7 plus 2s is equal to 3 plus t, because we know the 2 x's will be the same when the 2 lines cross. Okay, so we did that. And then we want to just kind of collect like terms, so I'm going to subtract 3 from both sides, so 4. I'm going to take my 2s to the other side, so I can make it, actually I think I'm going to go the other way, it doesn't matter. So 2s minus t equals -4. Doesn't really matter which side you move things to. Okay, so that's one equation I've got. Okay, let's call that equation number 1. Okay, let's take another equation. Let's do the y's. So 2 plus s equals 9 plus 5t. And I'm going to move things around so that s's and t's are on one side. So s minus 5t. Move that over. Move the 2 to the other side. So I got 7. So I'm just putting like my unknowns on the left side. So that's equation 2. And then finally I'm going to equate my z equations. So I got -6 minus 3s equals 13 plus 5t. And I'm going to put my s's on one side again. Okay, so I think just to make mine all positive, I'm going to go negative 6 minus 13 is negative 19 equals 3s plus 5t. And that's equation 3. Okay, and I could just write my, you know what, I'm just going to do it like this because I can. I'm just going to write this because I want them all to be on the left side. I'm just going to rearrange that to make it like this. Cool. Okay, so now I've got 3 equations and just 2 unknowns. So what I want to make sure is I want to find a value for s and t. I want to see if the values for s and t are the same in all 3 equations. So let's do it. So we can pick just 2 equations to deal with, and I think I'm going to pick equation 2 and 3 because I'm noticing that they already both have a 5t, which is kind of handy. So then I can do elimination. So I'm going to take equation 2, s minus 5t equals 7, and then I'm going to take equation 3, 3s plus 5t equals negative 19. And I want to eliminate a variable so that I'm able to solve this equation. So I'm going to add my equations together. So s plus 3s will be 4s. Negative 5 plus 5 would end up being 0t, so that's eliminated. And then 7 plus negative 19 will be negative 12. So I know 4s equals negative 12. So I want to solve for s, so I'm just going to divide by 4. So I know s is equal to negative 3. Okay, and now I want to solve for t, so I'm going to use, so I used equation 2 here and then equation 3. So I'm going to just use one of those again, so I'll use equation 2. And I'm going to find out what t equals. So equation 2 is s minus 5t equals 7. So I sub negative 3 minus 5t equals 7. And I just isolate t. I'll get negative 5t equals 10, so t will be equal to negative 2. So now I've solved for s and t in equations 2 and 3. So I want to make sure that holds true for equation 1. So I'm going to take equation 1, which was 2s minus t equals negative 4. 2s minus t equals negative 4. And I'm going to check to see if those are in fact the values of s and t that work for equation 1. So check out my left side. 2s minus t. I'm going to sub those in. So 2 times negative 3 minus negative 2. So I just subbed in s and t. So I got negative 6 plus 2 equals negative 4. And then if I look at my right side of my equation, it is negative 4. So cool, I just proved subbing in s and t that holds true for equation 1. So it should be good. So now I just want to find out what my point of intersection is. So to do that, I'll pick an equation, like a line, 1 or 2. Okay, so say I picked doesn't really matter. Say I pick line 1. So line 1 was equal to 7 to negative 6 plus s to 1 negative 3. And since I just proved that s equals negative 3, then I'm just going to sub that in. So 7 to negative 6 plus negative 3 times 2, 1, negative 3. Okay, so I'm just going to do that. So I'm going to multiply the second vector by negative 3. So it'll become negative 6, negative 3, and 9. Then I'm going to add my vectors together. So I'm going to have 7 plus negative 6 is 1. 2 plus negative 3 is negative 1. Negative 6 plus 9 is 3. So this is the solution. 1, negative 1, 3. So that's where that's the vector, but that means it's also a point. It's also the point where my lines would intersect, 1, -1, 3. So I can turn that vector just into a point. Another way to solve that, just letting you know as an alternative, I could have used line 2 and subbed in t equals -2, where instead of an s it would have had a t. So that's how you solve for intersections in 3 space. And I'll just tell you one more thing while I have you on here. Let's just talk about the skew situation, since you hadn't seen that before. So if you want to give this a try, here's the line, -2 plus s, 1, 2, 3, and then we'll say the second line is 201 plus t, 2, -1, -1. So I'm telling you right off the bat, these lines are skew. We can't really tell, but we can look at our direction vectors and we know they're not parallel or coinciding because they're not scalar multiples of each other. So we know that they're either going to intersect or be skew. So you would set this up the same way we just did the last one, like parametric equations. Make your parametric equations equal to each other. And then you'll have 3 equations. You can sub 2 of them into each other. And then what's going to happen to you is when you go to check s and t, when you're going to check if they're, like, you're going to solve it and you're going to get answers for s and t, and then when you sub those into, say, equation 1, the left side and the right side are not going to equal each other. So you're going to run into a problem when you get to this step here. Okay, sorry, I just can't actually scroll up. Okay, so yeah, remember how we solved for s and t here and here, and then we went back to equation 1 and we checked our left side and our right side and they were equal. Okay, so for the skew lines, the left side and the right side are not going to equal each other, so you're going to run into a problem there. So yeah, hope that helps.